In this video, we're going to learn about geometric figures, permutations, and combinations. The differences between permutations and combinations. Permutations are arranging of people, digits, numbers, alphabets, letters, colors. The keywords are arrangements, arrange. The second one is combinations. It tackles about the selection of things, menu, food, clothes, subjects, teams, and the keywords are select and choice. The first one is permutation with repetition. It has a formula of n raised to r where n is the number of things to choose from and you choose r of them. The example is a lock has a 5-digit code. Each digit is chosen from 0 to 9 and a digit can be repeated. How many different codes can you have? So we are given with n is equal to 10 as it signifies the digits 0 to 9 and r is equal to 5. If we're going to solve the number of codes, this gives us n raised to r or 10 raised to 5. Further simplifying it gives us 100,000 codes. The second one is permutation without repetition. We have the formula as n factorial all over n minus r factorial, where n is the number of things to choose from and you choose r of them. Sometimes you can see the following notation for the same concept as the permutation of n r is equal to n permutation of r, or if we're going to further simplify this gives us n factorial all over the quantity n minus r factorial. Let's proceed with the example. How many ways can you order 3 out of 16 different pool balls? We are given with n is equal to 16 and r is equal to 3. If we're going to substitute the following values on the formula, this gives us 16 factorial all over the quantity 16 minus 3 factorial. Further simplifying it, this gives us a final answer of 3,360 ways. Let's proceed with the first type of combination. We have combination of repetition or combination with repetition. The formula is the quantity n plus r minus 1 factorial all over r factorial multiplied with the quantity n minus 1 factorial, where n is the number of things to choose from and you choose r of them. We have the example, if there are 5 flavors of ice cream and you can have 3 scoops of ice cream, how many combinations can you have? You can repeat flavors. So we are given with n is equal to 5 flavors and r is equal to 3 scoops. If we're going to substitute now the values of the formula, this gives us the quantity 5 plus r minus 1 factorial all over 3 factorial, multiply it with 5 minus 1 factorial. This gives us 35 combinations. So we have the second type as combination without repetition. This has a formula of n factorial all over r factorial, the quantity of n minus r factorial, where n is the number of things to choose from and you choose r of them. Sometimes you can see the following notation for the same concept as the combination of the function of n r is equal to n combination of r. We have the following as n r is equal to n factorial all over r factorial quantity n minus r factorial. Let's proceed with an example. The state lottery chooses 6 different numbers between 1 and 50. To determine the winning numbers, how many combinations are possible? For this type of problems, lottery problems, okay, we're going to use the following formula as n factorial all over r factorial, multiply it with n minus r factorial. If we're going to proceed now with the solution of this problem, n is equal to 50, whereas r is equal to 6. Okay, so further substituting the values using the formula, this gives us 50 factorial all over 6 factorial multiplied with the following quantity as 50 minus 6 factorial. And then further simplifying these quantitative values gives us okay, 15.9 million combinations. Okay, that's a lot of combinations to win this lottery. So we have geometrical figures in permutations and combinations. In this next slide, you're going to tackle about the different formulas only. Okay? The number of triangles formed by joining the angular points of a polygon. The number of triangles that can be formed by joining the angular points of a polygon of n sides as vertices are. We are given with the following formulas: n multiplied with the quantity n minus 1, n minus 2 all over 6. The second one is the number of quadrilaterals formed by joining the vertices of a polygon. A number of quadrilateral that can be formed by joining the vertices of a polygon of n sides are, and multiply it with the quantity n minus 1, n minus 2, n minus 3 all over 24, whereas n is greater than 3. Okay? And then we have the third one, the number of triangles formed by joining n points, out of which m points are collinear. Consider there be n points in a plane out of which m points are collinear. The number of triangles that can be formed by joining these n points as vertices are n combination of 3 minus m combination of 3. The number of triangles formed by joining n points out of which no 3 points are collinear. Consider there be n points in a plane out of which no 3 points are collinear. The number of triangles that can be formed by joining these n points are n multiplied with n minus 1, n minus 2 all over 6. We have the fifth one as the number of straight lines formed by joining n points out of which m points are collinear. Consider there be n points in plane out of which m points are collinear. The number of straight lines that can be formed by joining these n points are n combination of 2 minus m combination of 2 plus 1. The number of straight lines formed by joining endpoints out of which no points are collinear. Consider there be endpoints in a plane out of which no points are collinear. The number of straight lines that can be formed by joining these endpoints are n multiplied with n minus 1 all over 2. The number of rectangles formed by using horizontal lines and vertical lines. The number of rectangles that can be formed by using m horizontal lines and n vertical lines are n combination of 2 multiplied with m combination of 2. The number of diagonals formed by joining the vertices of a polygon. The number of diagonals that can be formed by joining the vertices of a polygon of n sides are n multiplied with n minus 3 all over 2. Now that ends my presentation. For further questions, you may message me through my messenger account or our LMS inbox. Thank you for listening.